Hey guys, there's that radio again. Working on this Delmonico. It's going to try to make this a short one. I restrung the tuner. Matter of fact, we'll try to include some still pictures of I did some work on this tuner. I actually added some grommets. Completely redone the tuner section. I found that the tuner gain capacitors themselves were soldered. The way they did it, they soldered it to this tuner subchassis, which had the grommets in it, which were then fastened to the main chassis. Well, come to find out, I've been having a lot of weird issues with that, and I got to look and I noticed that the tuning gang had become unsoldered from the tuner subchassis. So I went in and resoldered all of that, cleaned all this old solder off, went back in there, fresh clean solder, resoldered all 4 connections. So that should help some of the noise issues that's having. Then I added, I took some more grommets, cut them in half, and put them underneath the existing grommets. And then I had some, oh, there's the air conditioner now. Let's see. Had some of these little spacers right here. Yeah, let's see. I think there's, I forgot, I don't know what the dimensions are. A little over 1/8 inch. Anyway, they fit perfect through the center of the grommets. So I just cut them to about 1/4 inch length and put those down in there, and then ran the mounting screws through there, and now this thing is perfectly level, perfectly centered, and doesn't move. So I've stabilized that. Then once I got all that done, I realized that something wasn't right with this dial cord, that it just something did not look right. So I wound up restringing the dial cord. I wound up replacing the dial cord, matter of fact. Let me see if I can get you out over here. Give me a little Chinese pointer. Yes, I completely restrung this dial cord. Look at this. This wheel is on backwards. I'm sorry, it wasn't on backwards, but just look at the space I have now between these screws, and let me see if you can see it. I have plenty of space. I've got over 1/4 inch of space between the dial string and the tuning. See if I can turn this a little bit. There we go. Yeah, look at that. Plenty of space. Also, the spring is not in this section of dial string anymore. I moved the dial string, the spring, over here to more conventional location, which is like you'll see on a lot of other tuning, string tuning section. This spring needs a little love, but I think I've got it. I really honestly think it might be a little too tight, but it works. It does proper now. When I turn the shaft to the left or clockwise, you see the plates opening up on the capacitor. That means it's going higher in frequency, which indicates that the dial pointer is going up, which indicates going higher in frequency. So that should be right. So I went ahead and repaired the mounts, resoldered the gain capacitor to the subchassis, completely restrung the dial cord. So that's going to cure a lot of problems that this thing had. The next thing that I'm going to do is these little polyester, I call them nylon caps. That's what we used to have. Like I told you before, the little horizontal output sections of these old TVs I used to work on back in the probably about mid 70s. They used these things across a horizontal hold coil, and these things are always going bad. So just my curiosity is about to kill me. I'm about to warm up my equipment and I'm going to pull one of these dudes, and I'm going to measure the value on it to see if it's right or not. So I'm going to do that, and I'm going to report back when I'm done. So anyway, when I get it out, we'll measure it, and we'll see how it checks. And my curiosity should be sated. Alright, catch you in a minute. Oh, and there was one other thing that I wanted to mention real quick. The other day when I was working on this chassis, it was like I told you before, it's intermittent. And I found a couple of things over here in the tuner section. The tuner section, if I just bumped on it with my little Chinese stick, it was very sensitive. At the time, I didn't know. Right there is one of the tabs coming off the tuning gang, another tab, another one, and another behind all these filters. But anyway, they all had to resolder all those. But anyway, the other problem I had was right there. See if you can see it good. This resistor, this 22K resistor, this lead was touching. Let's see if y'all can see that. It was touching this post. It was shorting out against this post. I just had to pull that lead up out of the way. But the other thing that I found is right there. See that? This little 270K resistor was broke. It was just dangling right there. Barely touching. And it looks like it's across a 200, can't read that, 250 picofarad cap to ground. So I wanted to look at that. That is off the FM first FMIF coil. So let's look at that. Let's see if we can figure out what that is. I'm going to have to replace that resistor. Ah, there it is right there. Look at there. That might make a difference in how this IF is working. That 270 broke. That's going to affect how this tube operates. That's pulling that tube to ground through this 270. So the bias is wrong on that tube. So that might be one reason this FM acted so squirrely. So I'm going to go find another 270K and replace it. So that'll be take care of that. And then tomorrow, hopefully, I can get back on this and let's try to do another alignment, and we'll go from there. So I just wanted to show you guys that. All right, bye. Yeah, sub update 1042 and a half. This is the 270K resistor. You see the lead is broke. Get my little Chinesian pointer. The lead is broke right off. That's how I found it. And this was going. This is in parallel to a 250 picofarad capacitor going through the secondary side of the first IF transformer, 10.7 IF transformer, to the grid of the 6AU6, I think. I'm sorry, the 12BA6. I don't know where I got 6AU6. Anyway, that was not in the circuit anymore, and it definitely needs to have that to work properly, wouldn't you think? Why would they put it in there? Anyway, this is the 250 picofarad capacitor right here that it was in parallel with. So I'm just going to, while I have it out, I'll just do a little check. Since I seem to be in a capacitor checking mood tonight. So let's see here and get my fingers away from it. Let's see if you can see it. Here we go. It says 248 picofarads. Picofarads. Anyway, I think it's good. So I'm going to put the resistor in there, and it was the leads between the resistor and the capacitor were intertwined or twisted. I don't know if there was a reason for that. It was the way they had it routed was kind of weird. I'm going to try to duplicate that, because you never know in these receivers the way they do things. Like I said in the previous videos, Everything in these receivers is probably tuned by moving one component next to another. I don't know, but I'm gonna try to put it like I found it, and then tomorrow hopefully I'll have time to get this thing tuned. Hopefully when we get this thing tuned and ready and operating, then I can work on the case. Anyway, I think that's all the updates, unless I find something else. Bye.
There's a pretty good chance that we can have you sleeping better.
All right.
With our 12-month same as cash and our
Back on this
options, it's never been easier to buy. Come see us across the police station, North 7th Street in West Monroe.
Delmonico.
Mattress out, you don't have to go into debt to get a great night's sleep.
Join Mark Patrick seminars and lose the weight or stop smoking guaranteed for only $49.99. Weight loss seminar Thursday, January 27th at the Hampton Inn.
I think I've about gone
5:30 to 7:30 p.m.
as far as the alignment on this thing.
Are you considering a career change or maybe looking to move up in a career you already have? That dream comes true at Mid-South Extrusion, considered one of the area's finest employers.
I believe.
In production and maintenance positions, and they're hiring now.
I think I've gone.
And most importantly,
This is the weirdest aligning radio I've ever seen. It should be straightforward, but it's darkening. I had to turn the lights off. This radio align had a perfect response pattern on that thing when I sweeped it with the alignment generator. The thing didn't work worth a flip. So basically I just, to align this thing, let me turn some lights on. To align this radio, not the best way to align one, but honestly, the news wore off this radio already for me. I basically used the signal generator, the SG80 signal generator, to generate stereo signal into it, and applied it to the 10.7. I applied a 10.7 to the front end, as weak as I could get it, and looked at the dual trace scope with the monitor and the decoder output, and I just slowly tuned each IF coil for minimum distortion. It works. I've actually used a Synad meter to do this before. Matter of fact, on commercial FM, that's what I used to use, was a 12 dB Synad meter. It works. Anyway, I tuned it for minimum distortion, and I was able to get a lot better response. There was also one coil, well, one transformer that I forgot about. I was doing the primary. I wasn't doing the second. I was tuning the primary off, but I wasn't doing the secondary. But it turned out nice. It's doing about as good as this little cheapie can do. I think the way this thing is made is very rudimentary. It picks up stations. It decodes. It sounds good. It's got adequate separation. I didn't measure it, but I think for what this thing is, and I think it's going to be good. Now, what I did find was the pilot indicator did not work. Turns out the little neon bulb was dead, because everything was right. The signals went through the stages and everything, and it should have worked, but it didn't. And I decided to statically test the bulb. In other words, I took the little neon bulb out and put a 100K resistor in series with it and put it on my variable AC bench supply, and I got it up to 120 volts, and it never fired. And then I pulled the other one off that was identical to it, that worked, and it would fire about 80 volts, which is about right. So that that little neon bulb was bad. So I dug around in my junk and I found a different kind of neon bulb. I don't have an NE55. I'm gonna look around work, see if I got one, but it worked. I just clipped it in front of the in place of the old one, and I was able to see my stereo indicator this time. So right now I think the FM stage is about as good as it gets. Where I'm at now on this thing is recalibrating the dial. In other words, when the dial says 600, it should be 600, and if it says 101 FM, it should be 101 FM. So I got to recalibrate that. All that went out the door when I redone the dial string. So I'm going to do that next. That ain't no big deal there. I'll just I got to put it back and take everything loose, all my test stuff out. Go ahead and fix the neon bulb permanent and get that done, and then I'll put this thing back in the case and get my pointer realigned, and I can realign the tracking and everything and the tuners, and that'll be that. Other than the volume control itself, it does not go all the way to 0. I think the volume control is probably bad, but I'm going to take it apart and give it a good cleaning, because it's probably just build up on that section. It's probably from me washing it, probably from dirt and grease build up, probably from when it was in the kitchen. So that's about all I got to do to that, and then I got to clean the inside of the case out, put it back in the case, and I'll be done with it until I decide to do, to redo this, restore the case, which will be later, because I don't know how to do that. I have never done that, so I'm not ready to learn now. I've got other projects that I want to do, so that's where I'm at on this. So anyway, I don't think I'm going to rehash what I've already done once, so I guess the next time you see this, it'll be operational, and we'll give it a go through. Anyway, talk to you later. Bye. Hey guys. Sorry, hadn't had lunch. It's had a big breakfast this morning, but it's like 2:30. I'm snacking on some Hickory Farms smooth and sharp cheddar blend. I like cheddar. I like sharp cheddar. Pretty good. What's that guy's name? Terry? Forgot what name his YouTube channel was. He's always working on electronics, and he's always drinking wine. Well, I don't drink wine. I just eat the cheese. Anyway, on this Delmonico that I've been working on, couple of things. Let me give you a proper update. Now, I've had several videos that I've recorded of updates, and I don't know how many of them, but where I'm at right now, I have this thing playing really good. I've got the AM working good. I've got the FM working, to me, about as good as I think this thing's going to do. I did inadvertently, during my FM trials, inadvertently adjust the AM where I should not. The AM IF coils, I had to go back in and redo that. But this is the FM detector stage right here, and the preamp, which detects the FM audio. This is the FM ratio detector coil. This is the last in the IF stage. You got your FM mixer oscillator right here, and then you got your first IF stage, and then your second IF stage, third IF stage, and then your detector, your 10.7 detector, and it just sends it's got a ratio detector, which is on the secondary side of this transformer right here. There's a center tap that goes through a filter network and sends that decoded audio to the function switch and also to the decoder board. So it takes that detected audio, it sends it in here, and then this right here picks off the pilot and doubles it to 38 kilohertz. This tube here is strictly for detection of the pilot to light this indicator. And of course, this right here generates, amplifies the pilot first off. It then generates the drive Let's see. Let me remember how that works. See. Yeah. Okay. I apologize. This tube here. This tube right here takes the incoming multiplex audio. The multiplex is the multiplexed FM and FM stereo signal that comes from the detector. It's got all that crammed into it. So this receiver stage has to be pretty wide, tuned pretty wide, because it's 192 kilohertz just about. So it's got to have a wide bandwidth, which means it can't just simply peak it for max, because it could be way off. So that's why I just went ahead and adjusted. I couldn't get the sweep to turn out like I wanted it to on this radio. So I just wound up coupling 10.7 into the antenna input, which served to add that 10.7 to the grid of this mixer right here, oscillator mixer tube right here. And that allowed me to tune the IF stage. And basically I just put in a low level signal into this 10.7 megahertz signal from the SG80 with multiplex, and I was looking at the recovered audio on the oscilloscope left and right channel, and what I would do is I would just tune each stage for minimum distortion, and it seems to work really well. I actually tried doing the sweep marker generator on this, and it turned out horrible because it looked great, but for some reason or other I have never been able to get a good sweep generator, or to get a good FM sweep. I don't know why. I know I must be doing something wrong. I'm pretty sure of it. So I just did it the old-fashioned way. I really don't know. To be able to couple this, I needed to be able to detect the IF. However, to detect the IF, I needed to be on this transformer. And that transformer in other words, what we can't see here, because I did a lousy picture on this, I know this is crappy. This is your RF detector right here. I mean your RF oscillator mixer right here. What number? What kind of tube? That's that 12 BA8, I believe it is. Anyway, it's a twin triode. Anyway, this is the preamp for it. This is the oscillator mixer right here. Anyway, I injected my 10.7 here, which basically made it to its way to the grid of this tube right here. This is your first IF transformer. That's A, which is this transformer. You tune the primary, which is on the bottom, I think, and the secondary on top. Tune it for minimum distortion, and then I come over here to B, which is this one here. Tune the top and the bottom and the top for minimum distortion with a weak signal into it, weak 10.7 megahertz signal, a multiplex signal. Alright, so went on to the next stage. I tuned B. I already said B, I apologize. I tuned A and B right here. So let's see, that would have been this dude. So I tuned this one here. Then this is the stage I was talking about a few minutes ago, that I need to be able to look at the output of this signal right here with my detector probe to be able to get a accurate sweep. However, anything I did right here in this plate circuit would detune this transformer. I tried picking off here, but it just gave me such weird looking response. It didn't make any sense. So what I wound up doing is my probe, the probe that I made, the modulator probe. Yep, here it is. This is the Syncor 39G. White it out. 39G FM detector probe. This right here is the BNC to the detector probe input of the SG80. But anyway, this blue lead right here, as you can see, goes through a .001 into the detector. That right there is what gives you your trace. I could not get that to work properly, and I don't know exactly what. Well, let's wait it out. I don't know exactly what I did wrong. I just went back and tuned it like I'm kind of used to on commercial rigs, which I know is only plus or minus 5 kilohertz. But being this is plus or minus 75, and then you've got your multiplex and your pilot and all that. I mean, you got your pilot and your RDS and all this stuff like that right there. So these things have to be tuned pretty wide. Anyway, I was able to get that correct. I got it sounding fairly good. It's fairly sensitive for what it can be. The only thing that I have to do now is get the tuner to track, get the tuner dial to track properly with the front, make sure it tracks the, that's what these two adjustments here for. One's for the oscillator, one's for the tracking. And once I get that done, I'll have to do the AM2, because when I've redone the strings, just do this whole alignment off right here. So I've got to put this back in the case, find out where this pointer is on 600 or something that I can get to easy, and also the FM frequency, and mark it like I did the other day. And once I do that, then I'll be able to take it back out and realign, you know, basically just touch up the oscillators in this to where it tracks. Now the pilot light, which indicate a stereo, the stereo pilot indicator did not work. It was a little neon bulb. I broke the bulb trying to use the envelope. Thought I was being smart, but it's just a little neon bulb that they use, and that neon bulb, let me find it right. There is it. Let me find it. Have my ducks in a row once more. Right there. This 12BA6, which is this tube right here. It's this tube, this coil, that capacitor, that resistor. The main things in here. Basically all this does is it takes this signal right here from this 12EEW8 38 kilohertz amplifier, or this is where your FM is demodulated. The FM stereo is demodulated in this stage. But anyway, it just takes a signal off of here, comes through this 100 picofarad capacitor into the grid of the 12BA6. It's amplified to around 20 volts peak to peak. Anyway, this showed a center tap transformer, but it was not a actual transformer, it was a coil. Now it may have been this, because I could not find, all this was this right here. I see where I marked this out. This plate come into the center tap of this, what appeared to be a center tap coil. Your B plus come from the power supply here. The output come to your plate. I'm sorry, the output was apparently like a double-ended coil here to double the voltage. But anyway, this side come through a 22K through the neon bulb, come back around to B plus. Well, that wasn't the case. This is how it was wired up. This plate come over here to this side of this single coil, which only had two connections. You know, axle lead coil. It only had that connection here, connection here. Didn't have nothing else. So I found the capacitor, measured the capacitor, measured the coil, 88 ohms at 60 millihenries. For, you know, ever had to have that information. Anyway, so this plate is tied here, then the B plus is tied here. So anyway, I measured around 20 volts, I think, peak to peak on this side. which meant it was considerably more over here. So the neon bulb was bad, so I just replaced it with something I found in my junk box, a little Radio Shack, little cheap indicator. And the bulb is a little bit smaller than an NE55. I'm trying to decide if I want to use it or not. But anyway, that's kind of where I'm at now. I've already adjusted the separation, and the separation, if you look, this is like a buffer amplifier. This these plates right here this is B plus coming right here to these two resistors, feeding plate voltage to each one of these tubes. This V10 is of the 17 EW8. This is half. This is the other half. Anyway, let's look at the plates. The plates. This is the plate drop-in resistor, plate load resistor, if you want to call it that. Here's where your signal comes out. Goes through a 10K. Goes through a little filter network right here, and this right here is marked right, and that goes to the high side of the volume control. This here does the same thing, except it's the left side. Okay, so here comes your detector. Detector out. Simply just feeds the input of each one of these tubes. If you look, the separation control, all it's doing that I can tell is adjusting the gain of these two tubes. It does nothing. So basically what I did is, when you switch from FM to FM stereo, if it's not set correctly, there will be a difference. And this is what I found out. No documentation that I could find anywhere. I wish there was. Anyway, I adjusted this separation control to where the FM and the FM stereo sound audio levels were the same. In other words, I was looking at my scope at the audio levels coming out of this detector. I wanted them to be where they would be the same. I can't see where it really affected the separation. Of course, I didn't really do a whole big test. But stereo signal and a mono signal, or a non-stereo signal, the amplitude were the same. So that's how I adjusted it. This control right here, this VR right here, this 3K on the 12BA6, best I could tell is that set the threshold for this bulb right here to light. In other words, if you basically, this thing is just sitting there, you know, it will, apparently it's going to fall. It is false. It was took me quite a bit to get it to actually pick up on a stereo signal, but you don't want and then not have it flicker or anything when you're listening to a like a mono signal or something like that. So that was kind of a tricky, but this is kind of a simple little demultiplexer. I think I could have maybe designed better. I mean, that's an inaccurate statement. Anyway, I think I'm done with that. So right now, all I've got to do now is figure out how to mount this, make it look a little bit better than it does. Second thing that I've got to do is recalibrate the alignment pointer here. Other thing that I have to do is I adjusted this one inadvertently. This is LM3 and this is LM2. I need to make sure I need to reset this. I need to check this again because I may have that off. I inadvertently adjusted that because nothing is marked on the schematic. This right here is a 19 kilohertz trap. I need to go back in and adjust this to where if it's a trap, then it needs to trap 19 kilohertz right here. So I need to make sure that's adjusted right. Now I have to go back to my theory to remember how to do this, but it's got TP1 here, TP3, TP2, let's see, TP1, TP2, TP3, and honestly, I'm going to have to read the book to see what exactly how you're supposed to do that, because I'm really not knowing what it expects. Anybody want to help me out on that, they can. But anyway, I've kind of babbled on too long, so basically I'm going to do this. I'm going to get this dial pointer adjusted where it needs to be, fix this up permanently, the pilot indicator, and I'm going to touch up the tuning in this FM stage and make sure I got it right. But I'm going to sit down with the FM theory book to make sure that I'm doing this right. So now I have to be a little bit coherent about what I'm talking about. And then the other problem that I have is the volume control does not do its job. And if I turn this all the way down, I still hear plenty of audio coming out of the left channel. So I'm pretty sure it's got wax in it build up that I've got to get out of there. I think if it give it a good cleaning, I think it'll be fine. I've got the safety cap that I got to install on the line input of this, and then I got to, once I get all that done and recheck it, I'm going to clean the spider webs and all the junk out of the cabinet, put this back in the cabinet, and I'm going to button it up until I get to work on the case, which will be sometimes. Anyway, that's where I'm at. Bring you back if there's anything special. Alrighty, boys and girls. Still got several things I got to wrap up on this, as I've stated. But what I want to do right now, I want to check the resistance of this volume control. Remember, I cannot turn the volume all the way down. So what I'm basically doing, I'm just unhooking the center tap, and I'm going to unhook the high side of the volume control. I really need to change this tip on the soldering iron to a smaller tip, kind of a heavy duty tip for what we're doing here. Alright, so what I'm going to do, for those who don't know, on these controls you have a semicircle. I'm going to draw you some fancy schmancy drawing here. It's going to be a hunter special. Well, I tell you, this is the finest in nap cattery you'll ever see. Anyway, the inside of this pot, this is the center or portion of the potentiometer or the volume control. That's where the shaft goes through inside. What you're looking at is a little hang on, inaccuracy. Really looks like something else, doesn't it? Anyway, the inside of this pot, if you just pull the back off of it, you look in here and you'll see this little black thing in the side, and that's where the resistance is. This is actually a carbon film. So the center right here, you see the center contact, that's the arm, or the center arm, and it contacts this arm that turns when you turn the shaft. So the shaft is connected to this arm. So what that does is this has a wiper on it. This little arm right here has a wiper on it, and as you adjust the pot, that wiper goes from this side of the control to this side. So if this side right here, ground, this side here, audio, this side here, very rudimentary drawings. Anyway, it's like this is the signal that comes in from your detector. So it comes here to this side right here. this is ground. So what this wiper does is you turn the as you turn this volume down, this wiper travels along the resistance of this what do you call that? We'll call that the resistance portions of the pot. In other words, the closer you're the wiper, or the closer you get to turning it to zero, your wiper gets this resistive material gets lower and lower resistance as you get to the ground side. And theoretically, when you get close to this area here, you should not hear any audio, because say like if this is a 100,000 ohm pot, now you're 100,000 ohms away from that and it's grounded. Think of it as a variable voltage divider. So the more you turn it this way, the higher the resistance between the input and the output, because now this say like you have it right here at the 10 o'clock position, now you've got a lot more resistance in relation to this. So say like if you had the pot right here, now this is a volume pot, which means it's let's say logarithmic pot, and that has to do with how the human ear hears. We hear things logarithmically, not linear. So as you get closer to this right here, the resistance increases or decreases rapidly. But anyway, if you turn this pot up here, it's going to get maximum loud. If you turn the pot all the way down here, it should go to zero, because basically you're grounding the signal out here that's feeding the tube of the preamp or output, whatever. The problem is when I turn this down, this resistance is not going to zero, because I'm pretty sure there's wax buildup in here, or not wax, but kitchen grease buildup on it. So that's what I'm trying to do now, is I want to measure with an ohmmeter. I have no clue how much resistance that is. I'm thinking it's 100 mega ohm. So basically, I'm just going to go in here with my my trusty dusty old voltmeter. If I can get it to, I guess my batteries are getting weak. I want to see how much resistance. Matter of fact, I'm going to measure it with my Fluke, my old Fluke 8010M. See what the total resistance is, because the damn schematic doesn't tell you. Something we need to know anyway. I'm showing 1990, almost 2 megs. Let's see what this one does. Measuring about the same. So this is about a 2 meg pot. Okay, now we know. So basically all I'm going to do is I'm going to measure from ground to the center tap of that control. I'm going to measure from this ground. In other words, when you turn the volume all the way down on most amplifier or radios of this age, or amplifier, whatever, when you turn the volume down, the you're really running that the center portion to ground. In other words, I should be getting, in other words, when I turn that control from maximum to minimum, the resistance here should decrease to almost zero. That's what I'm looking for. And I'm just going to hook my meter up, my analog meter. I'm going to hook it from ground to the center tap on each one of these controls, one at a time, and see what happens. So I'm going to turn the control up all the way. Alright, let's see if we can find the ohm meter. Okay, that's maximum right there. I'm reading 20 times about 2,000, so I mean 2 megs, so I'm reading about 20. I couldn't get my meter to zero all the way. I think my batteries are getting weak, but we're just gonna call it 20. Matter of fact, you know what, I got a better idea. let's use bad boy right here. We will use my trusty dusty old, let's see here. We will use my trusty old B&K model 177 vacuum tube voltmeter. I'm partial to this because this is the type I had when back in the late 70s I was a television repairman, radio and TV repairman. But what I want to do is set this up for ohms. We're going to set this up for 100K so it will measure. Oh, boy, am I special today. I'm going to zero it out. Ground your probe. And then unground it. Set your ohms for infinite. We're ready to go. So I'm on the R times 100,000 scale. Let me zoom in just a skosh. And I'm going to turn this control. I'm at maximum right now. I've got the center, the minus side of the ohmmeter, or the VTVM, to ground, which is where what the pot references to, and then I'm the positive lead of the meter is attached to the center. So basically when I turn this from maximum to minimum, I want to see A, how smooth it is, and B, how low resistance it goes. Here we go. Turning it down. Alright, right now I haven't fully gone all the way down, but we're still at 300,000 ohms. We're at 200,000 ohms, 100,000 ohms. And look at there, it didn't go all the way to zero. Let's change it to 10K. Let's change it to 1,000. So I'm on a 1,000 ohm scale. Let's see, so I'm reading 250. Let's make sure we're still calibrated. Yep. So we're reading about 220 ohms with the volume control all the way down. Well, not quite zero, is it? Let's do the other one. Bring it all the way back up. And I'm just going to turn it down. That one's reading about 350. I apologize. I don't know how to read my own meter. I'm so sorry. I'm a dumb butt today. Let's do this again. I don't know how to count. Turning it all the way down. I'm reading about 2,200 ohms. Okay. Doing the other control, other side. I'm reading about 3,500. So this control is definitely not doing its job. And pardon me while I go back to school to learn how to multiply. Big jerk. Okay, so anyway, I proved my point. I think. Thoroughly confused the hell out of y'all or something. I proved my point. What I suspected all along. I knew it. I didn't really have to measure it. But now I have a reference. The control is definitely not going to zero, and it should. So, what does that mean for us or me? I'm going to take the control out, take it apart, clean it, and then retest it. So, with that being said, this is a dual control. Siamese. It's not really Siamese. Let's see here. Let's see if I can get it out. Yeah, to get a bigger. Yeah, to get a bigger soldering iron. Come on now. We getting it. There we go. Yeah. Yeah, this control this control, let me get y'all zoomed in more. I'm really just taking it out. It's really no big deal. You just mark where your leads are, which wire goes where, so you can put them back like you found them. And once you unhook everything, use a little screw on the front of it. There's your dual volume control. Controls your left and right audio. As you can see, or may not see, they are joined. So the trick is to get this open. Oh, and this says 1 meg. Huh, interesting. Maybe I don't know how to read a voltmeter again. Let me remeasure this. I'm set on the kilo ohm scale of my Fluke digital meter. I'm on the 2000 kilo ohm scale, which is, let's see what this thing measures. Measures 2,000 ohms. I mean 2 meg. 2,000 kilo ohms, which would be 2 megs. Yep. I don't know, boys and girls. Not looking good for the home team here. Hoping I don't have to replace this control. Let's see if I can get it. Let's see if we can get it apart without breaking it. Let's get that out of the way. Let's get our work surface here. But y'all don't need to look at my ugly face. Let's see if we can get y'all to where y'all can see what the heck I'm doing. Check my battery level. There it is. So let's see, where do I want to start? First I'm going to start by not using my good cutters to do what I need to do here. There's that guy again. Oh, hang on. Cheese attack. I'm going to be able to poop for a week. I need to take that jumper off. Can y'all see? Now it's relatively painless. Now that I got that done, I don't quite know how these are done. I have an idea. So you got to start somewhere. So let's see. Let's look at this. And you'll see. I sure as hell can't. This is the control right here, and this section here seems to be joined to this section here with this little piece right here. So I think I'm just going to take this cover off. I don't think I have to take that cover off. I'm going to leave it on there. I think if I want to add another control, that this would you would take that cover off. Hell if I know. Anyway, I'm going to take this little slip right here and pull it very carefully without breaking it. I'm going to try to open this up by just prying that little tab. Where are you? Prying this little tab right here out, pushing this apart, and do the same thing here and see if this thing will come apart. That's my plan, you know. Very, very carefully. Been several that I've successfully taken apart. There's been some of them that didn't come apart. They broke. Then you're forced to have to solder the things back together. need a screwdriver, and I don't feel like getting up and getting it. But I really ought to in the name of let's not tear something up. I don't want to have to cuss in front of you guys. Here we go. Can y'all see? So far so good, and I'll see if it'll separate like I think it will. It will not. So maybe there's something else hidden under here that I don't know about. Like old Mr. Carlson says in his video, let's look at this together. I like Mr. Carlson. He's really sharp. He's sharper than I ever wished I could have been. But his videos are not really. Videos are not really geared toward the people that already does this stuff. Well, I know y'all can't see nothing. That's what's inside that first cover, guys. Right. I ain't sure which way to go with this, so turn you off. I'll figure something out, I'll come back. Well, I got a little too carried away, guys, and I just caused myself a world of trouble. This pot, this dual pot, which was working, it just wasn't turned down. Guess if you can't turn it down, it wouldn't be worth the crap. Anyway, in me trying to figure out how to separate this, because it looked like there was a way, and I just got a little over ahead of myself, I apparently broke. That's me. That's what happens, kids. If you're not patient, it will bite you in the butt. But this resistive element right here on the back wafer, I broke it. You can't pry this stuff. You can't be like Gorilla in it. You can't be exerting all your pressures out from the world on this stuff. This stuff is super delicate. It ain't like I could pick up the electronics distributor and say, hey, I want a dual control. But on the other hand, it's a 1 meg control measuring 2 megs, and I cleaned both the front half because I could reach it, and it didn't make any difference. So either way, the control is bad. I'm going to have to replace it. So it looks like that's the end of this for a while until I can find a replacement. So that's where I'm at. Yippee skippy. Alright guys, stay tuned. It'll be a year or two. Bye.